prove the identity, sine to the fourth x plus cosine to the fourth x is equal to 1 minus 2 cosine squared x plus 2 cosine to the fourth x. Now what we're going to do is we're going to manipulate this right side so that it's equal to the left side. And so first off, we can see we already have our cosine to the fourth x, it's just that we have two of them. So what we're going to do is we're going to split it up into cosine to the fourth plus cosine to the fourth. And we're going to leave this cosine to the fourth off to the side. And these three terms should combine, somehow manipulate them in order to get sine to the fourth x. And so obviously we want sine, and so these cosine terms we can turn into sine terms using the Pythagorean identity. Because cosine squared plus sine squared equals 1, that means cosine squared is 1 minus sine squared. And this actually, because it's to the fourth power, it's 1 minus sine squared all squared. And again, we're going to keep this cosine to the fourth x just over to the side. Here I distribute the negative 2 to 1, so I get negative 2 and plus 2 sine squared x. And here you can see I split it up into the squared into two factors. And if you FOIL this, you're going to get 1 minus 2 sine squared x plus sine to the fourth x. Once again, the cosine to the fourth just kind of sits there. And you can see we have 1 minus 2 plus 1. That sums to 0. We have 2 sine squared x minus 2 sine squared x sums to 0. So all we're left with is sines to the fourth x plus cosine to the fourth x, which is equal to our left side. And our identity is proved.